Okay, so this will be the section 2 of the FSM 204 course. So in this also we have this recorded session, which is by Dr. Sunil Jha. We have all this, and then we have the labs. So this lab is mainly for unsupervised learning and predictive maintenance, but it is divided into three parts. So one is the 2A, then we have 2B, and then we have 2C. So the lab is already available here, and the data set which is used is either available as a file.
Can you share your screen?
Okay, sir, not shared my screen. Sorry. Just a second. Mhm. Yeah, it's visible, right? Now it's visible, right?
Yes, it
Yes,
is
sir.
Yeah.
visible.
So the section 2 is also having a recorded session. And then we have the lab for unsupervised learning and predictive maintenance, which is basically divided into three parts: 2A, 2B, and 2C. And the needed files are either available as a download like this, or they have the statements, or you can say steps of how to actually get the file. So some files are the basic examples already available in MATLAB, and some are the MLX file which we have created. So they are both available. So we just have to follow the steps in given in the video, and then using these file, we just have to complete those. So these are three different parts mainly. And then we have the assignment also. So these are the steps for assignment, which Sridhar will be able to explain once. So these three sessions will be kind of very easy to follow since everything is already shown in the video. So just need to follow the as same as the video. Sridhar will now explain the lab 2 assignment once. He will just explain how and uh, how to execute these steps. So Sridhar, can you take over?
Yeah, hi. So, hello everyone. So, before starting, I would just like to know whether you have you gone through the labs or any of the exercise, or have you used any MLX file for that?
MLX file I think I have not used.
Sridhar, in
Okay.
which example we are going to use it for first time? Like
Actually,
two only, I
for
think, no?
how to A, we are going to use MLX file because
Okay, so
the
this one,
one
yes.
interesting feature about MATLAB is there are couple of or ample of reference material available along with a lot of examples. So you can load the examples by simply copying the command. There is a MATLAB function called as open example. So after open example, whatever name of the example you write, MATLAB will automatically load it from the available database of MathWorks. So in this section mainly we are using and understanding the examples available on the MathWorks database, or and also some MLX files created by us. So that's why I'm using. Have you ever till now, have you used any of the command and loaded MLX file directly from web to MATLAB?
Maybe you can show Sridhar.
Okay. Yeah. Just wait for a while. Okay. So I will start with the
Share your screen, no?
recorded lab session 2C, because 2A, 2B, and 2C everywhere you have to follow the same steps. So I will start with 2C because there are again some interesting lines that I would like to introduce you.
Your screen you have to share first.
Yeah. Okay. Yeah. Wait. Yeah. So uh, is it being shared?
Yes, yes, it's visible.
Yeah,
Please.
okay. So there are mainly three components, 2A, 2B, and 2C. So we will go with 2C. Okay, so this is mainly a predictive maintenance demo. So you have to perform the steps that you will see in that you have seen in the this recorded video, right? The recorded video demonstrates, and this you have to perform. So I have written the steps here. So what it says is copy the following command and paste it in the command window of MATLAB. So this is the command: open example in bracket readment / similarity based RUL examples. So the moment I paste,
Maybe you need to share full screen. I think on now the
yeah,
screen is not
yeah,
visible.
exactly. I shared a window actually.
Maybe share just full Chrome. That will work.
Yeah.
Are you using offline or the online version?
I'm using online version.
Okay, then the share screen. Yeah, great.
Okay, so I've been working with this MATLAB previous. So what I will do, I will clear the workspace. So clear all is a command. So whatever work you are doing in MATLAB, by pressing the clear all, you will clear your existing workspace and other folders. And CLC. So whenever I paste this command in the MATLAB command window, MATLAB will automatically load this example, which is not even on my system, which is on the MathWorks database. So that is being loaded. So the moment you load this database, first thing you have to do is by default the outputs are being displayed. All those lines are there, so output are being displayed. So right click on that and clear all output, because the main goal is to understand the codes and understand the structures of this example. So it's better to first remove the outputs and then analyze the code by section. And there are two methods, like you can run section first, second, third to get the individual outputs, and or even you can run all at once. So this is the way that you have to follow this entire section 2, right? In some cases there are MLX files provided, and in some cases you have to use this command, like pasting the command in the command window.
So if the MLX file is already available in the portal, na, FSM skills, you can just drag and drop in the same window, it will be uploaded. So there are some cases in which the MLX file is available, for example, 2A, and there are some cases in which we are using the examples. So at least you will be able to understand both. So if the file is available offline with you, you just need to drag and drop it inside this environment. It will already be loaded. And if we are using example, so like Sridhar has already shown, just copy and paste the command and the file will be loaded.
Excuse me, where to get this keyword of open example predict integer? This example name, where to get it?
Okay, so whatever examples we have chosen for this course are there in the course itself. Like here I have pasted the command. So, and other than that, if you are seeing some examples on MATLAB documentation, for example, I will tell you.
Okay.
These steps are I have shown in the course itself. So here you will see two options in every example: open in MATLAB online or copy
Okay.
command. So if you click on open in MATLAB online, it will I will tell you this also. So I'm
So there are
clicking on
a lot of examples already available to learn more about the different techniques. So that is always there.
So after clicking on MATLAB online, it has been popped up in my existing MATLAB online window, right? It has been loaded by default, and if I and here it is a copy command. So if you are using the installed version of MATLAB, you can simply press on copy command, and this open example command will get copied, and you can paste it in your command window like I did right now. Open example and this. So and it will get loaded, the MLX file, which is a live script file. Yeah, and how you have to perform this is demonstrated in detail in this recorded session.
Sridhar, can you also just take a second to explain the difference between a data set and the LMX file? What is the difference between the two? Just a
Data
second.
set and
The MLX file, the script, the live script file we are using now.
okay, so data set is actually a CSV file or a file which contains the data, and MLX file is a live script. So in MATLAB, we work with two things mainly. One is a script file and another is a live script file. So the difference between is that a script file is similar to what a conventional programming that we do. For example, if we are using C, C++ or Python, we can say that we are using a script file. So script file is similar to that. I will create one new. Here are options: script and script files. So if I click on script, the script is popped up. So I have to write entire code in one go here, right? And the advantage, so if I press on run, then the all code will get executed. And the main advantage of using the script, live script is that you can divide your code into multiple segments. For example, in this example also, here are various things that the creator has written down. So this is also we can do in live script. The information we can put it lot in the live script, and also the code is segment by segment. This is the first code segment. Then the section output is displayed separately. Then there is a next section, then another section. So section by section you can execute your code or you can write your code. And why MathWorks Training Academy or MathWorks example use live script is because of the same thing. It's very easier to demonstrate or to explain what the code section is all about. So here you can see everywhere there is a lot of description given. So it's better, it's easier to learn. So that is why we use MLX file. So MLX file is a programming file, and dataset is a data that you have to import in your MLX file. I hope you have understood. Here, yeah. So you can see the first line of code: URL equal to HTTP and some website name, then web save. So this link contains the dataset, and
So
this
this one will
dataset
be
is
assignment,
pasted
right?
in MLX file. So I hope it satisfies. Is it clear, sir, or do I need to?
I think it's clear to everyone also, right?
Yes, clear.
Yes, yes.
So we can move with the 2C, I
And
think now.
another change you will observe in recorded session, the logic is a bit different. The video in which you will see this first data preparation, some lines are different than they are present in here. So here what we are doing, MATLAB also has features to download and to use the dataset directly from the web resources. So here what we have done, I have pasted the link of the data file where dataset is available, and there is a web save function which is the URL function is the file that will be get saved, or it is the name of the string. So the web save function is what it is doing, it is saving the link into this name, correct? So the turbo engine degradation simulation data.zip, this file is being saved directly from web by using the web save function, and the unzip function is unzipping it and the degradation data name, and then this file is automatically the file handling is all together being done by MATLAB. So it is another advantageous stage in MATLAB. Yeah. So we will now move to the this assignment lab 2, right, sir?
Yeah, sure. Just give a small demo of how it's to be done so that they can follow.
So what we have to do? Do we have to wait for a while to let let
No,
others try?
we can start with the tools in this assignment. No
Okay,
issues.
okay. Yeah. So this assignment is about clustering, which is a type of machine learning method. And here we are demonstrating or we are learning the use of k-means clustering. Like it's a kind of clustering algorithm used in machine learning. So we are learning how to use that k-means clustering and how different distance metric methods we can use for k-means clustering. So you will get the clear idea after you see the video. But till then, I will just in a short will demonstrate how you have to perform this experiment. So here all the details have been given. You can read those and you can follow it. So first thing is explore the MATLAB documentation of k-means clustering. So like what we did. Okay, now I have
Yeah,
shared.
now it's visible. Yes, k-mean clustering.
K-means so just search on Google k-mean clustering MATLAB and the documentation will appear. Okay. So yeah, first thing you have to do is you have to read all those syntaxes, because same function is being used in MATLAB with different syntaxes for different purposes. So if you read it once, then you will get a clear idea. And then the next step is refer to the syntax and general information and k-means. Okay, and find the examples of partition data into two clusters. So partitioning data into two, first is train a k-means clustering algorithm, and second example is partitioning data into two clusters. So you have to do this thing either open in MATLAB online or copy command.
Are you having network issues or something?
I don't know, sir, because I'm using a web version of Zoom. I am sure what exactly happening.
Maybe
Yeah.
clear all and then explain. It would be better, I would say.
Yes, yes. Okay, is it appearing right now?
Yeah, it's visible. It's visible.
It's visible. Okay, okay.
Missing
Yeah.
maybe clear
So,
all and then start from zero.
yeah, okay. So first step, clearing all the outputs. Now the example has been loaded to the MATLAB, right? The MLX file has been loaded. So then you just go to this and refer the steps. Pasting, we have done this step, pasting the command window and MLX file is opened. And then observe and understand the program section. So uh, if you read that web version also, then there is a good example, good explanation of what all the steps are doing, right? All the stages are there, and their significances of each function, right? And after understanding that, you have to follow the next stages, understanding what is distance matrix method. So the documentation in detail available here. Yeah. SQ Euclidean, city block, cosine, correlation, and Hamming. So basically, at a glance, I will tell you that these methods are called as distance metric method. So in clustering, the data is being clustered, or it's an unsupervised way of learning, machine learning, where you are just plotting the data and you are making the clusters out of that. And those clusters are dependent on the data similarity. For example, if there are five kinds of parameters that can be drawn out of data, then you can segregate the clusters into five different sections. So that is what being done by those distance matrix method. Yeah, so here we are not using any external data set or real time data set. What we are doing is creating a random data set, or a data set of random points. So here the RNG default is the RNG is the function that is being used to create the random numbers, right? It's a function, and default, if we are using simply RNG, then in every experiment the random points that are being generated are different. And to get the same set of data points, we are using RNG default. So if you run the code 10 times, then all the 10 times data set will be same, or data points will be the same. And what we are doing with X is that we are creating two cluster data. Like, it's not the data is not supposed to be generated anything, but what we want is the data to be in a proper manner. So the X is actually a matrix that has 200 rows and 2 columns. So here the 100 rows are contributing to one. I will run it. Yeah, here you can see those data points are generated, right? And by default you can observe there are 2 clusters. So what we have to do from this code is to identify the different clusters and mark them with a cross mark or anything, or to make them highlighted, from make every point distinguishable and classification into all the clusters. So why we are using array n and ones function is to create random points with some common value. So first function, what it is doing is these have the values that are sampled, so that the mean of this normal distribution is 1, and they have the standard deviation of 0.75. So here it is a factor, like 0.75. So it has the standard deviation of 0.75 along with the mean is 1. So, and here the standard deviation is of 0.5. So we have used this function just to create 2 different clusters or 2 different observable clusters. So the task that you have to do in the assignments, if you read those following lines, the one is change the distance metric and observe the changes in clustering results. So read the second, change the randomly generated sample data to change the cluster pattern. So it is for 2 different clusters. If you add another statement like this, which have maybe standard deviation of 0.25, then you get another cluster here, right? And if you go down, then here is a distance metric method that you have to use. So here I was trying humming. So humming is actually a binary method. So I use this function. I will erase it and do city block. So if you load this example, you are maybe by default getting city block, because I got humming because I was prior to this session I was doing experimenting with humming. So I got this. Yeah, so here various iterations have been followed for this created data set, right? So what are those iterations are all about, you will also get to know if you when you watch the video and from this documentation. And you can see that these clusters have been created, right? 2 points have been highlighted differently. So the main task that has to be done in this is that now we have used centroids, right? City block. So if we change it from SQ Euclidean then the result might be different. So you can see that here the 6 marks have been there, right? So there are actually not 6 clusters. So, but why there are 6 marks has been shown, because we have entered here 6. So what this 6 parameter is about, the same information is there in this documentation. So if I put here 2, it will detect 2 clusters independently. Yeah, you can see that 2 clusters have been highlighted, right? One is of blue and then the second one is red, and every single point is classified into 2 clusters, right? We can see that. If I just enter here another, it is S Euclidean. Now I will add cosine, which is a different distance metric method. Then again, two clusters have been distinguished separately, and in early and even the points have been changed. Some this point in the initial example, maybe it was red, now it's blue. So these for different kind of examples, when your data set is too much complex, you will observe which kind of distance metric is best for different examples. So that is the main target, to understand them and to understand different kind of data. So two things you have to perform in this exercise. One is to add some other statements like that by changing this parameter or doing some changes. What you find, you have to experiment on that. How we can change this random set of points. And then next step is trying different distance metric method. There is another method which is Hamming. So and where do you find all these methods? They are in the documentation. Here it is a table where all the methods has been mentioned: SQ, Euclidean, city block, cosine, correlation, Hamming, and what they are all about is also written over here. So if I press on Hamming, it shows me an error that non-binary data cannot be clustered into Hamming distances. So this Hamming method will not work with this data set. So again, you can make a brainstorming on that, how you can convert this data to binary data, or to just make 1 or 0. If the number is positive, then it is 1. If the number is negative, then it is 0. So that may generate a different data set, and your Hamming method could work. So you have to experiment all those things and make a PDF of that. So everywhere you get these plots, you can take a screenshot of the clustered plot. As for clustered plot, I mean to say this plot. So you have to take a screenshot of this plot and you have to attach in a Word file with the situation or with the conditions. So what could be the parameters for this particular plot that we have changed or that we are trying with? One is obviously the data generation, and next is the different distance metric method. And not only these methods, all those things you can try. It is the 8. So 8 is the iteration that we are following. If you enter here 20 number, so there are multiple iterations that are going to happen, right? So these all you can experiment, and while experimenting you will understand how we can change it with something that how we can customize it with respect to examples. Yeah. And the last step in this exercise is that, which is additional, not a mandatory step. There is always option to add screenshots, but this simply you can try for understanding MATLAB in a better way. MATLAB has facility to save all the figures, plots, and graphs in PNG file, or in a SVG file, or in a JPG file. So what you can do is, here MATLAB is generating the plots, right? This is one plot, this is another plot. So you can add some statements here to save this plot into the file directory where you are, which is your current file directory, right? So that thing also you can get on documentation. I will tell you the name of function, which is save as, SAVEAS. So you will get to know the syntax of save as from documentation, and if you add just one line next to that, all those whenever you are running the code, those files are automatically being saved to your location. And while uploading the PDF or while creating the Word file, you can simply paste those all images in the Word file. So that's a task, that's a feature that will make your task easier. And this function is mainly there to plot the graph. So those points are being highlighted with blue, those points are being highlighted with red. There is a only cross mark. So all and here the legend is coming, which is telling us which cluster is what. So all these things are software defined, nothing happens on its own. So here we are defining all those things. So you can go through every part of this code to understand what is why we are getting exactly this graph, right? The color is mentioned. If I from R, if I put here G and run this section, then that will become green, right? So here everything is there in plot function. So that's also a thing that you can analyze and learn, and you can try multiple sets of experiments.
Great, Sridhar. So the idea behind this exercise is that we want you to change each and every line and test how it works. But main is the distance metrics only. But as many lines as you change and see the output, you will be able to understand better how it works. And a little background reading as already given in the videos, but if you are to do a little bit of background reading on the distance metrics, you will be able to understand which one to use in which scenario. That is also very important. We cannot use just randomly anything in any scenario. We need to
Exactly.
understand a little bit about it, where to use Hemming and where to use Euclidean. All these things we need to understand. So with the help of this example, you will be getting a very good idea about how they work, and then you can do a background reading on, okay, so this will help in this scenario and this will help in this scenario. So that is the idea behind this exercise actually.
Exactly. Yeah. And the more you do exercise, the better you are going to get familiar with MATLAB environment. So that's always beneficial.
Shreya, can you go to the FSM skills only back to FSM skills? Yeah. So a page back. Yeah. So in this, the 2A, 2B, 2C are the recorded labs which are already available. After doing those, you will be able to understand all the things you need to do in the assignment 2 also. So they are a kind of a prerequisite that you need to complete 2A, 2B, and 2C. So we can try that.
Yes.
Is it okay, Vinay? So
Yes, yes.
so
We'll
any
start this examples first, then we'll do exercises.
yes, please, yes,
Vaibhavji, I have a couple of queries.
please.
Yeah. In the first exercise in section 1, we have the one report to be uploaded of the that regression model. That report is generated, right, from our side. But the example exercise given, which is Avalon data,
Yes.
in which do we have to partition this data with this script, because this data is only one
Yeah,
data
yeah,
set
you
is one.
you have to divide it into train and test. Yes.
Okay,
So what
okay,
I've also done is, Sridhar, can
yeah,
you scroll up, please? Sridhar. Yeah. So go to this lab one, FSM
okay,
for lab one.
okay,
Yes. Just click on this, Sridhar, please. Yes. So one is available this video on the top, and the second video is of the lecture we had last weekend. So this also we covered there only. So I've already uploaded the recorded lab of the last weekend, na? Lab one which we took.
yeah,
So a lot of questions are already answered in that.
okay,
Specific,
okay.
yes.
Yeah, in the second exercise of classification, first we have to upload the report of human activity example, which is already carried out by you, but we need to do it ourselves, isn't it?
Yeah. So in
And
section, yes,
in that case, we have already performed this, but in generating report, uh, as per the regression script, if I write this script over here, then it won't. It is giving you a lot of error. The issue is that loading of the testing data
okay.
is not happening. So what should we do?
Shweta, can you go to this exact section? Yeah, back, and then just in section one only. You're talking about 1A, right?
Section classification problem 1B.
1B.
Yeah,
So in 1B, there is a guided lab and then there is a exercise, right? So you
yeah,
are
yeah,
facing issues in
yeah,
exercise.
yeah.
Um,
So in exercise, actually, we need to write script again, like we did it in regression, and then we have to generate a report. But in this case, what happened that when I run that test results, that predicted function command line, at that time the report is too big and the activities are scrolled down. There are a lot of data, so the report can't generate it. So shall we simply screenshot of that app classification app screenshot? Is it valid, or we need to generate report?
Wait, let me check just a second.
Yeah.
Hello, sir.
Screenshot
If
also would work, I think, right, Sridhar?
yeah, screenshot also work. Like if we get the more information about what errors you are getting actually, so we
Yeah.
could tell you a better solution. Or
Okay.
if the lines are too big, then you can simply same either paste a screenshot or you copy just those things and then generate the report.
Okay, because
That will also work.
I have used only regression classification app learner, and then I
Mhm.
have followed the whatever steps that is shown, and then report generation is the issue. So I will just prepare screenshot only.
Yeah, that
Okay,
would
okay,
work, no issues.
Okay,
that will work.
okay. And in Titanic, that data set, the training is equal to read table into bracket train.csv command is given. So that is making that training is the data set that is available.
Uh,
Training.
just a second. Which one?
Exercise for lab 1B, in which we have given the data set of Titanic, isn't it? In which we have three data set. One is table train.csv. Second
Yeah,
is test this thing. There are
yeah,
separate files are given. So
yeah, yeah.
we need to consider that training is the data set for training purpose.
Yes,
Okay. And we have to follow again the same procedure as we
yes,
did in the classification
yes.
data app. Okay, okay. Thank you, thank you.
So also, I would like to say, if ever within the week also, if you facing any error, just
Okay,
share the screenshot of the same in the group, and someone
okay,
will actually answer. So we don't
okay.
need to wait for the lab.
Yeah, yeah, yeah,
Yeah, the work should not be stopped actually. No,
yeah, yeah.
so don't
Okay,
worry about the time and date. Just whenever you
okay.
have any issues, please
Yeah,
post in group. So it will do two things. Like
yeah.
you will get the answer faster, and anyone else who is having the same issues will also be able to understand.
Okay, fine,
So
fine. No
please,
Yes.
problem.
yeah. So Vinayji, can we close? Is it okay? I think all the
Okay,
queries are
okay,
explained.
we can close this session.
Yeah. So what I'll do is I'll download this as soon as possible and upload in the same lab too, so that others who are not able to attend will be able to also see and then follow.
Okay, okay.
Okay.
Fine, fine.
Thank you.
Thank you.
Thanks a lot,
Thank
everyone.
you.
Thanks, Sridhar.
Yeah. Thank you.